All right, sweet. So over the next 30 minutes, we're going to talk about Project Livy. But first, quick introductions. My name is Anand Iyer. I'm part of the product management org at Cloudera.
I'm Praveen Mittal. I'm the engineering manager at SD Insight at Microsoft.
So when we started working on Project Livy, what were our goals? What was the key motivation? To put it simply, the motivation was to reduce the friction to use Spark. The whole mechanics of submitting a job, getting back results, managing Spark contexts, we wanted to make that as easy as possible so that people can just focus on their application logic. But we wanted to make sure that the full Spark API is still available in all its richness and flexibility. So that was the key motivation when we started on this project. So what is Livy? In simple terms, Livy is a service that manages long-running Spark contexts running in your cluster. It is an open source project, Apache licensed. It uses a REST-based interface. You communicate with Livy over a REST-based protocol. REST is a popular protocol, particularly among the application developers. It's easy to use. Livy lets you manage multiple Spark contexts simultaneously. It lets you do fine-grained job submission. Submit a Spark job as a request and get back the results as a response, either synchronously or asynchronously. And lastly, to make it easy for application tiers to leverage Livy to submit Spark jobs, we've built a client API. There's a Java API and a Scala API, and we're working on a Python API that will be available soon. Now let's look at an architecture to make things more concrete. So to your right, you have the Yarn cluster. Let's just say there's a cluster. It's managed by the Yarn resource manager. It could be another resource manager like Mesos. Then in the middle, we have the Livy server running on a dedicated machine. And then to the left, we have clients that are going to submit jobs. So Livy manages multiple independent Spark drivers, each with its own Spark context running in the cluster. Each context can be configured differently. Each context or driver can have multiple executors associated with it. And then the clients can submit jobs over HTTP and get back results over HTTP, submit jobs to the corresponding Spark context or driver. Now, Livy is an open source project. The key contributors are Cloudera and Microsoft. Our friends at Azure HD Insight have actually built a Jupyter Notebook solution with Livy as a backend. So this is a solution that's actually running in production on thousands of machines. And with that, I want to give it over to Praveen to describe how they leveraged Livy for their solution in HD Insight.
Thank you, Anand. Can you hear me? All right. All right. So how many of you guys know about Azure SD Insight? Have you heard before that? All right, few people. But let me quickly go over what is Azure SD Insight is. We offer a Spark service in the cloud, in Azure Cloud, and it's a fully managed service. It's 100% open source, Apache Spark and Hadoop bits. We have latest releases of Spark, and it's fully supported by Microsoft and Hortonworks. And one of the big features we have is we give you a guarantee of 99.9% of Azure SLA. That means the fault tolerance is very important for us. If we don't have that SLA guaranteed, and if you don't get it, we might even pay back money to you. We have all the certifications done for security and compliance because you're going to run your enterprise workloads over here. Besides being a fully managed service, we want to make sure that data scientists can easily come and experiment with it. So we have a Spark cluster which comes with the Jupyter Notebooks for that purpose. We also have an IntelliJ plugin where a dev from its own, from a dev box, connect to the Spark cluster remotely via Livy and do the remote debugging. And also for the BI tools and stuff like that, we have an ODBC connector. But that's not enough because Spark is just part of your solution generally, right? Generally use an ecosystem, and we want to make Spark simple, so we integrated with Azure Ecosystem. We have something called Microsoft R Server, which is based on open source R, but can work with 1000x more data and run 50x more Spark faster. It's right now integrated with our Spark. If you go to our portal website, when you provision Spark cluster, you have an option to have R provisioned with itself. We have something, I think we are the unique cloud offering we know which has Hadoop for the cloud. What does it mean? We have the data lake store where you can have, there's no limit to throughput. You can store petabytes of data, no limit of the size, low latency throughput, guaranteed with a remote storage with security built in. That means you have Azure authentication, multi-user authentication, and access controls for your files. At the same time, we integrated with the Azure Data Factory, which allows you to orchestrate your ETL pipeline. We also have Power BI connectors for rich visualization. Something new we did is, even for the Spark streaming, let's say you're running your Spark streaming jobs, you want to push your data to Power BI, it will automatically have a connector, push it for a rich visualization. We also have Event Hubs connector, similar to Kafka, already come with the clusters. And last but not the least, we also have Azure SQL Data Warehouse and Edgebase inbuilt with the Spark cluster if you want a fast storage and scalable storage for that. All right, so coming back to Livy. So how do we, as Anand mentioned, we use Jupyter Spark integration via Livy. So on your right, you can think of Spark as a sometime cluster. We wanted to decouple Jupyter and Spark completely, and we use Livy for that. So Jupyter submits a code to Livy, and it gets back results in text on JSON. And what we wrote is there's another incubated project it's called Spark Magic, which is Microsoft is working with the open source community, which runs within the Jupyter. So why Livy? Why did we do this? Why we select this architecture? This gives, as I mentioned, this gives a decoupling between Jupyter and Spark. It allows us to run the Spark code completely remotely, and we don't need Spark components to be installed with the Jupyter. So that way, we can move the Jupyter away from the Spark, away from the cluster, right? It has all the rich functionality of multi-language support, Python, Scala, and R kernels. Also, having this decoupling allows to have multiple endpoints. So you can have single notebook running multiple language, connect to single cluster or against different remote clusters. Besides, we have rich integration with Python library for data science and visualization. So even if we have decoupled them, we have all the functionality and rich functionality still is maintained. All right. So this is an SDI cluster. And one thing that I was mentioning that availability is very, very important. The fault tolerant and availability is very important because people are running their production clusters. So you have so this is an SDI cluster. Hopefully this works, but let me see. There's a gateway node where people submit Livy commands, and the gateway nodes sort of does authentication and forwards the request to the head node, which is represented as a head node 0 and head 1. Both the gateway has a lot of redundancy built in. It's not shown in a diagram, but there are multiple machines in the gateway, so there's a redundant there. Similarly, the head nodes have a redundancy with head node 0 and head 1. We have Yarn resource manager running on both the head nodes, and our drivers and executors are also redundant. So if there's any failures, it will come back and job will not fail. So when we started working on Livy a few months back with the Cloudera, Livy didn't have the fault tolerant. And the main reason was it has states which was in the memory. So if the Livy goes down and comes back, you are going to lose that state. So how we are going to go make Livy fault tolerant? So the things to do is simple. We're going to have Livy persist its metadata into Zookeeper node so that when the Livy goes down and it comes back, it can query the Zookeeper nodes and recreate its metadata state within the in-memory. So I forgot to mention one thing is we also have a Zookeeper node that comes in our cluster free of charge, so we just use that to store our states. So let's walk through this. A Livy command comes to the gateway. Gateway forwards it to the head node. Livy server submits the job to the yarn, and then the yarn schedules jobs to yarn. You get an app ID. Livy polls the yarn to get a job status, and you get a app ID back. So now, and that gets persisted in Zookeeper. So now when the Livy goes down and comes back, you should be able to go back and look at the job being resilient about it. But anybody who has worked in fault tolerant knows that there's a scenario that is this is not good enough. The scenario that it will not work here is, let's say you do a Spark submit and your yarn creates an app ID. But before Livy queries for that app ID, Livy dies. And so the Livy doesn't have got the chance to persist that app ID in the Zookeeper nodes. So now you have an orphan job. To solve this, what we did is we leveraged something called application tag, a unique tag that got, I think, start supporting Spark 1.6 and yarn with the yarn. So what we do here is whenever a new job comes in, we generate a unique tag always, persist in the Zookeeper, and then submit the job to yarn. And the yarn generates that app ID associated with unique tag. Now, in case there is a failure now, while Livy between the job was created and Livy queried the job to get the status, we should be able to use the application ID to get the app ID and persist in the Zookeeper. So this is how the Livy fault tolerant was done. I want to do a quick demo. So for that,
fingers crossed, everyone, we're doing a demo, a live demo.
It's a live demo. So we already have a cluster created for you in the Azure running right now, and we have a Jupyter workload. What I have done is it's a very simple RDT, fruits. I like fruits. So we created a simple fruits RDT. And what I'm going to do is I'm going to execute this command. And is executing this command is created. I want to go and show you the session. There's a Livy session over there. What I'm going to go to my Ambari dashboard over here, which has, you can see that Livy is started over there. I'm going to restart the Ambari, and I'm going to stop Livy here, right? And I'm going to go back while the Livy is getting stopped. I think it's a slow internet. We go back to the session. You should get a 5.2 error. So Livy has died. So I'm going to rebring the Livy and make sure that I can re-execute that Jupyter query. So I go back to Livy action. I'm starting it. So now Livy is restarting it. It's going to the Zookeeper, trying to get the state from the Zookeeper, and try to persist that in the memory. So looks like it's up here. Let's see. We have a session here. Hopefully we can execute this query. Boom, we can execute the query as if nothing has happened from the user perspective. So that's Livy demo for you. By the way, thank you. By the way, you can go to this website here where you can try the Spark on Azure for free. So give a try there. We have all the related link over there, what you talk about, Spark and Azure thing, Spark Magic, Livy, these are the open source projects. So come contribute on that sort of thing. And it talks about Power BI connector, Spark R, everything, the information you need. So over to Anand.
Thank you, Praveen, for the demo and the detailed description of how Livy achieves fault tolerance. There are a few more aspects of Livy's architecture that are important, and I want to touch upon those. So as I mentioned before, Livy lets you manage multiple different Spark drivers with their own contexts running in the cluster. You can have multiple clients talking to these Spark contexts. You can have multiple clients talk to the same Spark context. Each Spark driver and the corresponding executors, they're running in their own container. Each driver is running in an isolated container, so they don't step on each other's toes. So if one driver were to go down, it does not impact any of the other drivers running in the cluster. Another advantage of this architecture is multi-user support via user impersonation. So let's just say we have a client, and the client connects to Livy and authenticates itself as a particular user. So let's just say the client connects to Livy as user A and spins up a Spark context. Now that Spark context is running as user A. And what that means is that Spark context only has access to the resources and files that user A has permissions to. So you can have multiple users connect to Livy, authenticate themselves, and then they'll have independent Spark contexts running as those users, only having access to the corresponding resources. And this is a very important consideration if you're going to build multi-tenant applications with Livy in an enterprise setting. And speaking of applications, now let's take a look at the Livy Client API, which is the primary API you'll use if you're building an application that's leveraging Livy. There, as I mentioned, we have a Java API and a Scala API, and the Python API is still in development, and for now, I'll showcase the Java API. So the key interface to understand with the Livy API is an aptly named interface called the job interface. So the job interface has a function. The function is called the call function, and that's the function any implementing class would have to override. So let's take a look at an implementation of the job interface. So you have the call function, and the call function takes as input a job context object. This job context object has a reference to the corresponding Spark context. So within your call function, you have a reference to the Spark context. And what that means is within your call function, you can write any Spark code because you have a reference to the Spark context. So now let's actually look at how this job would get submitted through the client API. Step one, you create an instance of the client. You do that via a Livy client builder. You give the builder a set of parameters, and that will help you either initialize a new context or connect to an existing context. Once the client is connected, it will submit an instance of the class that implements the job interface. That instance is serialized, sent over the network to the corresponding driver. There, the call function is invoked with a reference to the Spark context. So all that Spark code in your call function is run. The results are serialized, sent back over the network. And here you can get the results either synchronously, or you can poll for the results asynchronously. Now, I like architecture diagrams. Architecture diagrams are always helpful to understand what's going on. So let's just walk through that flow with an architecture diagram. So you have your client application. It initializes a Livy client instance. Then it submits an instance of a class that implements the job interface. And you have that serialized instance sent over the network. And if I were to use more formal terminology, you're actually sending over a serialized closure over the network. It is then executed on the driver node. The call function is invoked with a reference to the Spark context. All that Spark code in the call function is run in the driver. The results are then serialized, and the results are sent back over the network to the client where they are deserialized, and that's it. It's as simple as that. Now your application has the results of the job that it submitted. It could submit it to a specific client. It could talk to multiple clients. You can have multiple clients talk to the same context, and so on and so forth. But the Livy Client API makes it that easy. Livy is an open source project. Now, we didn't open source it just because, hey, it's available, it's useful, why not make it open source so that others who care about it can play with it. Now, our goal is actually to grow a community around Livy. We want folks to play with Livy and help us extend Livy. We want you to build applications on top of it and help us extend it, find bugs, fix bugs, and then contribute stuff back to the Livy code base. So do check out livy.io. We do want to grow a community around Livy, so please play with it and send us patches.
Yep, I agree with Anand. You can count on Livy also, because one thing I want to mention is this is right now deployed on 1,000 cluster running enterprise workload, so it's well tested. So if you want to take the code, deploy in an application, you can do that. Also, yes, come join us, help us to make it better.